Everyone was like very patch on. So you just got everyone was just chilling. I heard that's just like this is the common list. I was trying to chill. It's just very impossible to take the hairy ones, so this is the common list. Watch Game of Thrones. I will be back. But it's really frustrating because it's a whole participate in all nice things in the same way I have to do in Irish. Yeah, I don't know if it's something all the right. Because the thing about Irish is that since everyone's going to be talking there throughout the day, they just happen to get all this. I'm going to have to maybe somewhere around the bridge. So I still have to do that currently. I didn't realize this week organized a secret Santa. Oh, I completely forgot. I completely forgot. Who's your secret Santa? Oh, I can't reveal that. But I'm not going to tell you. Oh, that's fair. I forgot how much it's good. And I bought it now. Right. He told me about that. He's like, I bet he's going to be. I knew he knew. Like some part of me, I knew he knew. What's that Halo game that you promised him for the burger? Oh, no. I got him, like little, bang. Cute. No, it turns out you can actually figure out password and secret Santa if you have N-2 connections, which means I know who it has. So it's not so secret. N-2 connections. So, and yeah, well, and connections between people, which is just an N, I suppose. It's not. Yeah, there's N-2 connections, because I do 3 connections already. Anyhow, once you know that, you can work out who has who you are. Because like 2 people can have the same person. It is one. Your question is Lily. That's right. How does Lily? Lily is Lily. Lily is Maria. Maria is me. Yeah, I worked out. Did I look at this? Mine was up here, actually. Great for fun. It was really accidentally told me that. I was thinking to myself, I was wondering who she had, like, who was giving her stuff. I figured, surely there's some way to solve the problem, right? Surely there's like a logical solution. I wasn't right over shit. I was like, oh, just draw lines. Because it's a Hamiltonian cycle, if I remember correctly. You ever did that? You did that. Did you? No.
I'm learning all this shit. It's early. This is. Oh, by the way, there's no recordings of the stuff on the board.
I never watch recordings anyway, but that somehow makes me sad. He told the guy who was behind me that he couldn't take a zoom behind me. When he wants to take a picture, he's like, don't take pictures.
No, but in macro, he was the same. But he started class by saying he used to take pictures of the board. You should be making notes.
Yeah.
He didn't do that this time, which is like I was like, well, waiting for it.
I don't want to jinx it, but we're in the right move.
Yes.
Isn't there a secret rule where if they don't turn up for the first 15 minutes, you can go home?
I don't want to go home.
Hi.
Do you have a set of the notes?
I'm
The first day you're coming to class.
Yeah, I've not picked them up yet, but I'll read one mine.
Okay. You've missed a lot of material.
I know. I'm going to catch you up.
Well, that's easier said than done, as long as I can tell you. It's not a good idea.
When's it like that? When?
code for today is 3555122. Sign a sheet. Thank you. Questions before we start? I'm sorry I'm a bit late, but it should be all right. Any questions on the material? Okay. That's all right. Things will fit in much later. But you've seen enough to work on problems at 1 and 2. Those 2 will be spoken about next Thursday. And as I said, it is important that you try. Do not, you see very few people in class, of course. That's because partly it's a difficult class, and partly because people give up very quickly. But what we need to do is understand that you will be required to do difficult problems on the exam. And the way out is not to memorize them, even if you spend 2 months doing it. That's not the point. The point is to try and work on them on your own and understand how they work. That will typically take care of your performance. All right, so I started on money the last time, simply saying what fiat money is for us. So fiat money, I repeat, fiat money is produced costlessly, fiat money is durable, fiat money is called fiat because it does not give direct utility to the plant. Okay, these are the key properties. So you want to start from there and do a couple of things. The first is, we want to show that very generally, if the time horizon is finite and fiat money is rationally valued, we don't want to get into stories about why people carry money saying, oh, it's because they're stupid. No, we don't want to do that. That's what we're doing anyway. Then fiat money will typically have zero value. Okay? And we need to do that. We need to prove that. And in the process, I will show you how one obtains the first order condition intuitively. And then show you how to obtain the first order condition by writing a Lagrangian. The reason we do both is because from there on, we will always work with Lagrangian. It will be a bit too complicated to do it intuitively. So that's where the Lagrangian will be important. But the intuition there is also important so you understand what's going on. Okay? And then, not today, but on Thursday, I will speak about economies in which agents' expectations are not rational, and yet, in a finite horizon economy, money may have value. More specifically, we will say when money will fail to have value. That will show us what's actually going on. Is it okay? So, we're going to look at a simple economy in which time goes from 0, 1 to capital T. There is no uncertainty, so it's a deterministic economy. Our purpose here is to keep things as simple as possible within which to prove a result. We don't want to put in lots of complications and say, oh, but I don't know exactly what happens, but that's the result. No, we want to be very clear about what we're doing. There's one physical good at each date. There are agents. Okay? There will be no loan margins. There is no borrowing and lending as such. But there will be fiat money. Okay? Present in the economy in the sense it will trade, and we'll see that that means it will have a price, etc. So the moment QMT, Q being the price of an asset, money is like an asset here. QMT is the price of money at date T. be looking at arrow-Radnor equilibrium. So the agent's problem here, now we're looking at things that we actually haven't seen at all before in this class. But that's the structure of monetary economies in general. So the agent's problem is, well, there is one good at each date, and there is money. Okay? However, money, of course, will not enter into the agent's objective function. So the agent maximizes something that I write here by choosing a quantity of the good to consume at date 0, a quantity of money to hold at date 0, a quantity of the good to consume at date 1, a quantity of money at date 1, etc., 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 all the way up to a quantity of the good to consume at date t, and a quantity of money to hold at date t. Some or many of these might be 0. That's a separate matter. We need to work that out. And we specify a simple form of the utility function. Okay, this is called discount utility. So there's a discount factor, which we, for the moment, we're assuming is common across the agents. This will not be relevant for the argument. And the utility from consumption at date t, and this is summed from 0 to capital T. So what this does is that your marginal utility at time t does not depend on your consumption at any other date. So it makes the computations easier. And this is completely standard. You've seen this, depending upon, I shouldn't say you've seen it, I don't know whether you've seen it in your second year. There are lots of things that appear in the appendix of the books. And I don't know how many people look at the appendix, I don't know how much of this is covered in class. But I know that you've at least been told about intertemporal consumption. And if you've been told about intertemporal consumption, you can't do it only with budget constraints. If you have first order conditions, that means you've been told about the utility function. Okay? But the key property here, as I said, it's not that you can't do it more generally, but it becomes more messy. The results are less clean, and it's just easier to work with this form, which is called an additively separable utility function. The key property being that marginal utility at date t does not depend on consumption at any other date. That's the point. Okay? Now, subject to, what are your budget constraints here? Well, this is a sequence economy. We're looking at arrow-Radnor. So at time t, what you will be buying will be units of the good, so PT, I have noted that, but PT is the price of the good. Whatever you consume of the good at time t, you also will be holding money. So any money that you purchase at price QMT, and the amount is MIT, and what you're restricted by is the value of your own endowment at time t, plus any money that you brought from the previous period. Right? Money is durable. So you can trade it at today's price, and the amount that you have is MIT minus 1. And this one will have a Lagrange multiplier, which I should denote by lambda IT. Is it okay? Please ask if something is not clear. Because from here on, the structure will be common for quite a few classes. Yeah.
Is that MIT and that's M1T?
This one is MIT, this is MIT minus 1.
Yes. Because you can bring from the previous period.
Sorry?
Because you can bring from the previous period.
Yes.
And then, and that just makes it generable for every.
Sorry?
And that makes it generalizable for every single period that you've got the I.
Now the I is for the agent.
Yes.
So, and this constraint holds at each t.
Yeah.
Yeah. Okay. So your capital T plus 1 such constraints. Is it okay? Yeah? And you also want non-negativity, which will sometimes play a role, sometimes not, but let's write it down. So XIT is always non-negative. More importantly, you cannot carry negative quantities of money. So the fact that you don't have loan markets ends up affecting things exactly because you cannot carry negative amounts of money. Okay? You can hold more money and then spend it, but what you cannot do is carry a negative amount, which is effectively taking a loan. That you cannot do. Okay, so all these are for all t from 0 to capital T. And you are, if you go back to date 0, if you look at this constraint at date 0, well, the amount of money that you brought into the economy, as an endowment, so to speak, will appear. So you need to say where that comes from, and we are simply going to say given MI minus 1 is not taken. So you don't start with any X. It's just to make sure that everything is consistent. Now we're going to say we are at an arrow right equilibrium. Okay, so at equilibrium, which we've already said, is arrow random, which we haven't defined for this economy, but you can imagine what it's going to be based on what we've seen so far. It's a specification of all prices, including the price of money at each date, okay, such that the market for the good and the market for money. Right? So we are not specifying that because it will not be important for our argument here. It will be important for other models where we will specify it. For the moment, that's not good. So at equilibrium, assuming that xit is strictly positive for all I and for all dates, so that this constraint is one that we can ignore. I say constraint, but it's one that has to hold for every agent at every date. Okay? Because that's going to interfere with our first order conditions. So to make our first order condition a bit simpler, I'm going to say this. Look, my argument's got nothing to do with whether I'm consuming 0 to minus. My argument will hold even if I'm required to consume a strictly positive amount of dollars. So that constraint, you can include it. It'll make the argument more complicated, but the germ of the argument is the same. Is it okay? So we're going to say that xit is strictly positive everywhere. Okay? The first order necessary conditions are, and of course first order conditions will also hold if you're not at equilibrium. We're considering equilibrium, so let's write it as at equilibrium. So, will be the following. Marginal utility of consumer I at time t will be equal to lambda it pt. Okay, so this is our usual first order condition from what we've seen so far. That the marginal product, marginal utility vector points in the same direction as the price vector. They're proportional. Okay, but this is at date t. Okay, because the lambda depends in principle on t. If you have just one good as we have so far, this condition really doesn't do anything. But it will be important when we look at models with two goods. Okay? So this is something that we are familiar with. The things that we are not familiar with, although you actually might be familiar with them, but I'll come to that later, is minus qmt times lambda it plus qm t plus 1 lambda it plus 1 less than or equal to 0 with equality MIT is positive. This is the messy one. This is the one that we need to understand. Okay? For the moment, let's just leave it the way it is. Let's just say, that's my condition, and I've told you. And then, since the economy ends at some finite date, I will also have what's called a terminal condition. Qm at capital T, lambda I at capital T is required to be less than or equal to 0 with equality if the amount of money that you have at the last date is strictly positive. Is that okay? Questions? Yeah. I haven't shown you why it's true. You get that here.
Can you explain the lambda section again?
Well, these are things that you've missed.
I know.
It's a Lagrange multiplier. So you need to look
Right.
at the notes, go through it. If you have a question, you come speak with me.
Okay.
Okay? It's a Lagrange multiplier. When I write the Lagrangian later, you will see where it appears.
Yeah.
Here, I've introduced it so that I can write the first order condition, so that the notation is here. Later, we're going to get into what these conditions, where they come from.
Okay.
And also do it with the Lagrangian, which is the mechanical method.
Yeah.
Okay? All right? So now, I'm going to need some space here, but I don't want to erase everything. And I don't want to move to another board either. I'm going to use the space in there. So what I want to do now is explain why we're getting that condition. So remember, the first order necessary condition typically is obtained for the following reason. You say that, suppose you solve your problem. Okay? If you have solved your problem, then it must be the case that by making small changes to that solution, you cannot do better. In particular. Any change will not allow you to do better. In particular, small changes will not allow you to do better. Right? So then you ask, all right, suppose I make a small change, by how much will my utility increase? And then you say that increase has to be less than or equal to 0. Okay? Now, when you are at what's called an interior point, these are the figures that we usually draw with two goods where you have the tangents here. I don't want to put it on the board. So both your goods are being consumed in positive quantities. There, you're able to both increase and decrease the amount of the good that you consume. And that gives you your first order condition with equality. Marginal rate of substitution equals the price ratio. Correct? Very good, hopefully. That's clear. Even if it's not, let's assume it is. The problem is when, even in those situations, the quantity of the good that you're consuming is at the boundary. So you're consuming 0 apples. Now what? That's your solution. You can increase the amount of apples that you consume, but you can't decrease it. Will that affect the first order condition? The answer is yes. That's what's happening. Okay? So in what way? So let, changing the notation instead of the way I have it here, just for the purpose of the argument, let x hat and m hat denote the values of x and m at the proposed solution. Okay? Hence, the words that I will write on the board are probably a bit different from what's on the notes. You shouldn't get thrown off. If you are, please ask. Okay? Hence, any alternative that is budget feasible, it has to be budget feasible. I can of course do better if I'm allowed to buy things that I can't afford. That's actually nothing surprising, at least to an economist. So, hence, any alternative that is budget feasible cannot increase utility. So that's the verbal argument. Now we need to type it in bits and pieces. So, suppose at t, you increase the amount of money that you demand by 1 unit. Okay, so if delta mi at t equals 1, plus 1. Right? Now, when we do that, when we look at the budget constraint, we are operating under the assumption that, of course, prices don't change. Your endowment certainly can't change. And this is called a local variation. So we are assuming that you do not bring any more money into the period. So you're looking at changes only on the left-hand side. Is it okay? Yeah? Then, I'm not writing out from the budget constraint, the change in consumption will be equal to, well, you work it out from there. It should be clear that the change in consumption will be minus QMT times 1 over T. Make sure that you understand this. So the right hand side does not change. On the left hand side, I change this bit by 1 unit, and therefore that bit has to change by corresponding amount, which is what? You move this to the other side, if you wish to, you get minus QMT times 1 divided by PT. Is it okay? Clear? Is it okay? Yeah? You might want, I don't know how much of the detail is available in the notes. If these are not there, you might fill them in. Otherwise, you might not follow later. Okay? Correspondingly, in the following period, I get to use an extra unit of money. Do we agree? Right? So, the change in consumption that I can afford at T plus 1 will be equal to, again, QM plus 1 over PT plus 1. Are you all right? Yes?
If I'm understanding correctly, this is saying that if you have a set amount of money in goods, if you buy one less good, so you have more money in one case.
The other way around. So I want you to think about it. You're right, but I want you to order it a bit differently. What I'm saying is that I'm at a solution. If instead I decide to carry one extra unit of money, because otherwise the computation will be a bit different, that's all.
Yeah.
One extra unit of money, then how much of the good must I be giving up at that date? And how much of the good do I get at the next date where I get to use the extra unit of money?
So
Exactly.
less goods today, more goods tomorrow.
Okay. Is it okay? Yeah? So now, how much will this change my utility by? That's my question. So the utility will change at the margin, right? Now at the margin, I know that my utility is given by that amount at any date. Correct? I'm saying that x hat, which denotes my solution now, okay, evaluating the marginal utility, the derivative, together with the discount factor, is the amount by which my utility will change. So the utility change will be, well, I lose utility at date t, so minus beta to the t, u prime I x hat, which is my solution. I'm making small changes from my solution, times the change in consumption. Right, that's where the minus sign comes from, so maybe write it this way. Times minus QMT 1 over PT. And then, in the following period, my utility will change by beta t plus 1 u prime I x hat I t plus 1 times the positive number qm t plus 1 divided by t. Do we agree? Is it okay? All well? Yeah? Now I'm going to start erasing there. That one we'll try and keep. So this is when I can increase the amount of money that I carry by 1. Now I'm saying that I'm at a maximizer. So the total change can be positive. I'm starting at a maximizing point. If I make changes, that's the value of the change. Since I'm at a maximizer, this change has to be either 0 or negative. Do we agree? Please make sure. If you don't, please ask. Why is a very good question to ask. If you find it, that's all right. So we are at a maximizer. I'm saying now, given that you're at a maximizer, suppose I'm still actually able to make these changes, which I typically will be able to do. But I will not make those changes because I cannot benefit. By definition, I'm going to maximize. Okay? So, at a maximizing point, delta MIT equals 1, then let me write that expression again. Now I write it with the minus sign outside. Delta t u prime I x at it given t over dt plus beta t plus 1 u prime I x at I t plus 1 given t plus 1 divided by bt plus 1 has to be less than or equal to 0. Cannot be otherwise. Is that all right? Now, if delta MIT equals -1 is feasible, if it's feasible. Why the difference? Well, look, I can always increase my money holding by 1 unit, even starting from 0. But if I'm already at 0, I can't reduce it by 1 unit. So if it's feasible, then you put in a minus sign here, all these things will change in sign, right? And you will get something similar, but not the same. Then, well, you get a difference in sign, that's all. This object has to be less than or equal to 0. Is it okay? Questions? Not clear so far? Right. So now we actually get to do what we want. So if m hat I be strictly positive, then delta MIT equals 1 and delta MIT equals -1 are both feasible but infeasible. Is it okay? You're at a maximizer, you can check by saying, well, let me increase my money holding by 1 unit, doesn't work. Let me decrease it by 1 unit, doesn't work. So both those conditions will work. Right? Which means what? Well, this one is just the negative of that one. Okay. So our condition becomes, I have to write this repeatedly, but it's still worth doing. Beta t, right, minus beta t u prime I x at I t u m t divided by bt plus beta t plus 1 u prime I x at I t plus 1 u m t plus 1 divided by t plus 1, well, it has to be exactly equal to 0. You agree? it's both less than or equal to 0 and greater than or equal to 0, it has to be equal to 0. That's called an Euler equation. So you can run out of space. We're right here. I'm aware of the fact that the name is often pronounced Euler, but as far as I know it's pronounced Euler, so I'm going to say Euler. And you might wish to check on them. Famous mathematicians start with Archimedes and Pythagoras. Euler would certainly figure there. Euler, Gauss, Bernoulli, Newton. Yeah. Newton and Gauss are considered to be the greatest mathematicians ever. You got Miss Newton. Is it okay? That's the easy case. But the difficult case is also one which we basically worked out. Okay, so this one is the Euler equation. So let me put a star here. Okay. Now what's the other case? The other case is one where you can actually increase your money holding by 1 unit, but you cannot decrease it. Okay. Alternatively, so this is the only alternative. Since you cannot hold negative quantities of money, I've erased the constraint. Alternatively, m hat it is 0. So delta MIT equals -1 is not feasible, budget feasible. Correct? So my first order conditions, and hence let me just rewrite. And hence minus beta t prime I x hat it 2mt divided by dt plus beta t plus 1. So which one am I writing? Yeah. So this is the only one that we need to consider. Beta t plus 1 x, not an n. Is the required necessary condition, necessary first order condition. This is an Euler inequality. Making sense? So the fact that you have a non-negativity constraint on money holding tells you that you have two different first order conditions. And both are important. You'll see why. They're crucial. Is it okay? Have you followed so far? Yeah? So now, I want to think about how to write these two different conditions together. Right? But the answer is fairly simple. I can write it that way, okay, and say with equality if the amount of money that I'm carrying is strictly positive. Because that's what the first one was. The Euler equation that we got was the case when m hat it was strictly positive. So I can write it. Okay? All well? Yeah?
I'm a bit confused
Yeah, go on.
by the first Euler equation. So,
Not first Euler equation. There is one Euler equation.
not the inequality.
Yeah, this one.
It's this one.
Yeah.
I can see where it comes from, I think, but it comes from the first thing we did, which
It
was
comes from both of these,
both of
which
those.
I've written, which had started over there, but then I've written it over here. If I'm allowed to increase the amount of money I hold by 1 unit,
Yeah.
The fact that I cannot increase my utility since I'm at a maximizing point gives me that inequality.
Yes.
If I'm allowed to reduce it by 1 unit,
Then you
the
get-
fact that I cannot increase my utility gives me the second inequality. The fact that I'm allowed to both increase it and decrease it, and yet I'm at a maximizer, says both of those hold, and therefore I get the equality.
Okay, but that's not the same as the bottom, the second one. That's the same as the top one.
This one is an equality. So when both of these conditions hold, then you get the equality. So if you're on the, if I draw a line and I say you have to be to the left of it, including the line,
Yeah.
and then I say you have to be to the right of it, including the line,
Okay.
then you must be on the line.
Right.
Is that okay? All well? Right. This is the difficult bit. Making sure that you understand what you're doing. Okay. Now, as I said, this is a standard first order condition with just one good. It's not saying very much. What it's saying is, given the resources that I have in a period, I'm going to allocate across the different goods in that period, or if there happens to be just one good. I'm going to allocate so that everything looks like it does in our standard image with two goods. That you have a tangency between the budget line and the indifference curve. That tangency is captured exactly by the first order condition in the Lagrangian. That's exactly what that is. Okay, so that bit is not a problem. What about this bit? Well, you see, the first bit says beta t u prime I t x I t is lambda I t p t. So I can rewrite my condition over there, which I'm going to do over here. Okay. Rewrite. What am I rewriting? So let me, it is that line there. So I rewrite my inequality. In what way? Well, beta t u prime I t x I t divided by pt is exactly lambda I t. I'm missing some price. Right? So I substitute for beta t u prime I x I t divided by pt. I use lambda I t instead of that. So I get qmt lambda I t. And similarly, for the next one, I get qmt t plus 1 lambda I t plus 1 less than or equal to 0 with equality if mi hat is strictly positive. But of course, mi hat simply denotes my solution, so I can drop the hat now, and I get exactly that first order. Is it okay? I still haven't said why I get this, the last of the first order condition. We get to that later. Is it all right? Now you see where the multiply comes in. The key idea is that one. How much money you carry at the margin is specified through a first order condition in the form of an inequality. Because it might be the case if you decide not to carry any money. It's too expensive for you to do that. You might end up not buying an expensive car because you can't afford it. Most of us have consumption which is at the boundary for the millions of goods in the world. It's just a few goods that we buy. For the rest, it's not that those goods are not available. It's not that we don't consider buying them. We can't afford them, so we consume zero quantities. So there is a first order condition, but not the one with equality. I don't know whether you've seen, since what we teach in maths has been changing for a while, I don't know whether your batch wants to see Kuntaka conditions. You did. This is Kuntaka. I don't know how it was taught to you. Okay, I'm sure if it was taught by Jorgen, it was taught well, but in a different context. That's a Kuntaka. And unfortunately, when you do monetary economics, you have to be or you do hand waving. Okay? Hand waving is easy, but it means you haven't really learned very much. It's all right to learn a little bit, but to learn it well. Questions? Anything that's not clear? Is it okay? Anything that's not clear, please ask.
Just to be clear with the
Sure.
the Lagrange.
I haven't set up the Lagrangian as yet.
Sorry,
I will, the Lagrange multiplier.
I meant the lambda multiplier.
Yeah.
That's just.
And you know, you will find me being quite brutal in the way I respond. Please don't take it badly. My purpose here is to teach you. My purpose is not to show you that you know nothing or anything. I hope you will learn. That's all. Okay? So I'll keep correcting you because otherwise you will end up saying incorrect things and that confuse you. Yeah, sorry, go on.
So the lambda
Yeah.
comes from negative beta t times the utility function divided by the price.
The lambda I know separately
Yeah.
from how first order conditions work.
Yeah.
I know that that condition, which I have not developed here, that condition must always hold because my consumption of the good is strictly positive. That's important. This is why that condition comes in. If that were not to be true, then I would get an inequality there as well. I would have to be even more careful. So I don't want to mess things up there. So that's where that condition, that's exactly the interpretation of the lambda.
I just linked those.
Yeah, don't worry about it. Keep asking. You know, this is bound to be confusing. You are required. This is why you're here. Otherwise, you just said, you know, listen to the audio, look at the notes, and you'll be fine. But you won't be in this class. This is why I'm here to answer your questions. Please. I thought you were asking something.
Yeah. Does this only hold then if you carry money from the last period into the next period?
No, you have an economy in which time goes on for T periods.
Yeah.
So these are what I'm trying to get across is that the first order necessary conditions are the ones on the board.
Yeah.
This one I haven't explained except by making reference to the too good economy with a budget line and an indifference curve, saying that
Yeah.
that's where it's basically that argument.
That's fine.
This is the one that required explanation,
Yeah.
which I have explained.
Yes.
And this will hold it for each agent at each T.
And then from that you can write out the utility change.
No. This is what we will be working on. What I have done on the board is explain why that condition holds.
Okay.
That's what I've done. And the next stage will be to teach you how to do things by writing down a Lagrangian, which has no intuition to it because you haven't learned these things. And I can't give you that intuition because this is not a maths class. Otherwise I would have.
Yeah. So you
So
just
the- Now writing down the Lagrangian, but it has to be done correctly. If it's done correctly, you will be able to derive those conditions on your own,
Okay.
which I will do. And from then on, whenever you write a Lagrangian, you'll know how to proceed. And that you will do on the exercise for many models. But for the moment, the purpose was to say, that is what we are interested in,
Yeah.
right? But none of you probably knew what that inequality means. Why do we get that? It was to make sure that you understand why you get it. It's really important that you understand why you get it.
Yeah.
What's the point in just asking you to do a bunch of maths about which you have no idea and how it relates to the economics? There is economics behind this. It's optimization, it's economics. Okay?
You'll be able to get that from the Lagrangian, right?
Of course you will.
Just like differentiating.
Yes, but that's the wrong way to
That's-
think about
that's
it.
the
I'm
bad-
asking you to first understand why that is correct.
Yeah.
In a relatively simple framework, where there is a role for money, etc. So that you understand what is happening.
Okay.
Because you will not be able to do an intuitive derivation of the first order conditions, which will have inequalities when we look at the models that we are actually interested in. These are all toy models, but even in toy models you have gradations. Is that okay? Now, I'm going to write down the Lagrangian. At least as much as I can. So, I'm not going to write the maximization again because it will take me time. It's the same as what we've seen before. So I'll just write it as, you should not do this. Okay? You should always write the variables. It's just that I'm running out of time right now. So I'm not doing it. Okay? So that was the objective function. Write the constraints, but write in the following form. Pt xit. I will not work out the Lagrangian today, but I wanted to put it on the board. Sorry, omega. Remove all the definitions. amount of money that you carried from the previous period minus PT XIT minus the money that you buy in the current period greater than or equal to 0. Always write your constraints in that form. Okay? With the multiplier lambda IT. XIT is also greater than or equal to 0. And I'm going to write a multiplier denoting rho IT for the X. And then MIT greater than or equal to 0, the multiplier will be mu IT. And you're given MI minus 1 greater than or equal to 0. This one is given to you. Is that okay? All right? So what's my Lagrangian? I'm going to write it directly over here by making small changes in what I've written, hopefully without running into difficulty. So the Lagrangian is a function L which depends on a whole bunch of variables which you have in the notes, so I'm not writing it out, okay, just so that you know. And you don't need to necessarily write it out in that form on any examples, just so that you know what you're doing. Okay, the Lagrangian is the objective function. And here, I'm going to multiply it by lambda IT. And take the sum from 0 to capital T. Done in a moment. Here, I'm going to multiply it by rho IT. Take the sum 0 capital T. Here again, I'm going to multiply it by mu IT. Take the sum from 0 to capital T. And that's given to me. That's my Lagrangian.